Composition of functions. The composition of two functions f of x and g of x is denoted by f composed of g of x, and this composition is defined as f composed of g of x equals f of g of x. We read this as f composed of g of x or f of g of x. Let's have example 1. What is f composed of g of x if f of x is equal to 3x minus 1 and g of x is equal to x squared minus 2x plus 1? So again, that is f composed of g of x is equal to f of g of x. As you can see in this formula, to answer this problem, to do composition of functions, in this case, we are going to evaluate our function f of x at the specified expression of our g of x. See, that is f of g of x. Meaning, we will substitute g of x expression in this value. So let's do that. That is, this is therefore equal to, we have, that is equal to f, and that is, what is g of x? X squared minus 2x plus 1. Okay, so x squared minus 2x plus 1. So again, you replace this g of x with its expression and then evaluate our f of x at the given expression f or x squared minus 2x plus 1. Okay, so let's do this. We have, again, what's our f of x? That is 3x minus 1. That is 3 multiplied by our x, which is this expression, x squared minus 2x plus 1, the g of x, then minus 1. So as you can see, please look closely. When we get composition of functions, f composed of g of x, that is equal to f of g of x, meaning we are going to evaluate the f of x at the expression g of x. So we are just going to replace our x here with g of x, which is x squared minus 2x plus 1, and substitute it here. That is 3 times x squared minus 2x plus 1 minus 1. And that is, simplifying, we have 3 times x squared is, we have 3x squared. 3 times negative 2x is negative 6x. And then 3 times 1 is plus 3 minus 1. Then combine like terms, we have the constant. We have 3x squared minus 6x. 3 minus 1 is 2. Therefore, f composed of g of x is equal to 3x squared minus 6x plus 2. How is it done? If we have f composed of g of x, this is equal to f of g of x. We will evaluate our f of x at x when at the specified value of g of x, or we will evaluate our f of x function at the expression given for g of x. So that is f of x here is the g of x, which is x squared minus 2x plus 1. And we have here f of x squared minus 2x plus 1. Substituting in our expression for f of x, we have equals 3 times x, which is x squared minus 2x plus 1 minus 1. And then multiplying, we have 3 times x squared is 3x squared. 3 times negative 2x is negative 6x. 3 times 1 is positive 3 minus 1, combining like terms. Therefore, f composed of g of x is equal to 3x squared minus 6x plus 2. Let's have example number 2. What is f composed of g of x if f of x is equal to 2x plus 3 and g of x is equal to x squared plus 3x minus 1? So again, we will evaluate our f of x at x squared plus 3x minus 1. So to do that again, we have to write f of g of x, which is this expression, x squared plus 3x minus 1. And then evaluating, we have our f of x 2 multiplied by x, which is x squared plus 3x minus 1, and then plus 3. Again, we evaluated our f of x at the expression given for g of x. 2 times the expression for the value of x is the expression of g of x squared plus 3x minus 1 plus 3. Let's simplify this. We have 2 times x squared is 2x squared. 2 times 3x again is 6x. And then 2 times negative 1 is minus 2 plus 3. And therefore, f composed of g of x, therefore, f composed of g of x is equal to, we have this 2x squared plus 6x, negative 2 plus 3 is plus 1. So again, we have f composed of g of x is equal to 2x squared plus 6x plus 1. That is evaluating our f of x at the given expression for g of x. Let's have example 3. Now, we have g here and then f here. So g composed of f of x and g of x is equal to negative 4x minus 4, and f of x is equal to x squared plus 5 plus x. Take note that in the first two examples, we have f here as the first function, and then g is the second function, and that is to be denoted as f of g of x. But in this case, we have g first, and then the second function is f. That is to be evaluated g of f of x, meaning we will evaluate our function g of x at the given expression for f of x. Let's do this, don't be confused. That is g of the expression for f of x is x squared plus 5 plus x, and that is x squared plus 5 plus x. And then we have our expression for g of x is negative 4 times the value of our x here is the expression for f of x, which is x squared plus 5 plus x. And then let's go back to expression g of x. We have minus 4. And then simplifying this, we have negative 4 times x squared is negative 4 x squared. Then negative 4 times positive 5 is negative 20. And the negative 4 times x is negative 4x minus 4. Simplifying this by combining like terms, we have negative 4x squared. Writing our final answer, we have negative 4x squared. Negative 4x squared minus 4x minus 4x, and then negative 20 and negative 4 is equal to negative 24. Therefore, g composed of f of x is equal to negative 4x squared minus 4x minus 24. Again, g composed of f of x is very different from f composed of g of x. Next, we have example number 4. What is f of g of 4 if f of x is equal to 4x minus 1 and g of x is equal to negative 3x squared plus 5? Again, in this example, we have a specified value for our variable x, which is 4. This is simply evaluating our f of x function when given the g of 4. That is, evaluate f of x. X here will be the value of our g of x function when x is 4. So in this case, we will first evaluate g of 4. So let's do that. We have that is equal to, this is g of 4. G of 4 is equal to negative 3 times. Again, we have uh, multiply it, no? Multiply it by the value of our x, which is 4. 4 squared, negative 3, negative 3, 4 squared plus 5. And this is equal to, we have negative 3 multiplied by 4 squared, which is 16, plus 5. Continue the process. We have negative 3 times 16 is negative 48 plus 5, and that is equal to negative 43. Okay? Negative 3 times 16 is negative 48 plus 5 is negative 43. This is now g of 4. This is now, again, g of 4. Thus, let's go back to our expression here, to our equation. Thus, this can be written as, f composed of g of 4 can be written as f of g of 4 is negative 43. See? So what did we do? In this case, we evaluated first our g of x function at the specified value of our x, which is 4. And then we found that the result is negative 43. Thus, g of 4 is negative 43. And we will be evaluating our f of x function at the value of g of 4, which is negative 43. There you have it. This is equal to, let's go back to our f of x expression, that is 4 multiplied by our x here, which is the g of 4, which is negative 43, minus 1. And we have negative 43 times 4 is negative 12, 172. Is that right? 4 times 3 is 12. 4 times 4 is 16 plus 1 is 17. Thus, we have negative 172 minus 1. And there you have it. F composed of g of 4, F composed of g of 4 is therefore equal to negative 173. Okay? So in this example, there is a specified value for our variable x, which is 4. And that is f composed of g of 4. To do this, we first evaluate g of 4. Evaluate our g of x function at x equals 4. And we did it, and we got negative 43. And this negative 43 will be the value of our x variable in our function f of x to get our desired f composed of g of 4. So again, f composed of g of 4 is equal to f, then g of 4 is negative 43. Simplifying, we have negative 173. Let us have our last example. Let f of x is equal to 2x minus 1 and g of x equals x squared plus 1. Find f of g of negative 3. So we have the same case. G of negative 3. Let us first evaluate g of negative 3, which is, so let me write it down, g of negative 3 is equal to, the expression for g of x is x squared. We can have it negative, it would be better if you put it like this, enclosed in the parentheses, negative 3 squared, and then plus 1. Again, this expression, evaluating g of x at x is equal to negative 3, for us to get a value, and we have negative 3 squared is 9 plus 1 is equal to 10. Therefore, g of negative 3 is equal to 10. And we will not stop there because we will be evaluating our f of x function at the g of negative 3, which is 10. And we have, that is equal to, let me write it down, we have f of g of negative 3, see, is equal to, we have our f of x function, expression is 2, we have 2 multiplied by our x is the g of negative 3, which is 10. Therefore, that is 2 times 10, and then we have minus 1, and this is equal to 2 times 10 is 20 minus 1. Therefore, we have our f composed of g, or it can also be written as this one, no? F of g of negative 3, we have equals 19. Okay? So if we have a specified value of our variable x, in this case negative 3, we first evaluate, no? The second function at the specified value of our variable, which is negative 3, and we did it. G of negative 3 is negative 3 squared 9 plus 1 is 10. Thus, G of negative 3 is 10. And then, we will substitute 10 for our f of x. That is, f of g of negative 3, g of negative 3 is 10, is equal to 2. The expression for f of x is 2 times x now is g of negative 3, which is 10. That is 2 times 10 minus 1. And we have 20 minus 1 is 19. F of g of negative 3 is equal to 19. This is composition of functions.